First, is it possible to calculate the size of angle C? Sorry, of angle ACB based on this information which is given? Remember, we are given AB, but we want to calculate this angle here. We are given this angle here, but we don't know the length of AC. We are also have the length of BC, but we don't know the size of angle BAC. Which means in triangle ABC, we cannot calculate angle BCA first. We have to calculate AC first. Are you following what I'm saying? You have to calculate AC first. So we have to use the cosine rule to calculate AC. Okay, that would be the best way. So let's calculate AC. Now allow me, this time around, I know that you're writing a test, but you need to get into the gear for area sine and cosine. Right? I can use capital letters. So if I want to calculate AC, I'll write here AC squared. Okay? Remember, last week I was using small letters, but I can use capital letters as well to write my cosine. So it will be AC squared. Now, AC is opposite angle B, which means in my formula I must add up everything cos B. So this will be AC squared is equal to AB squared plus BC squared minus 2AB times BC cosine of angle B. So that's my cosine. Okay? If you don't know the right to use the capital letters, then you can also use this what? The small letters. So if it was small letters, it would be B squared, small b squared. Then your AB there will be C, so it will be C squared. And then your BC is going to be A squared. Okay? And so on. Alright? So we have to use the cosine rule first. Now it's important for you to know that this question here is a higher order question because it requires you to apply now all the concepts, including your prior knowledge of Euclidean geometry. Okay? So AB is 10, so this will be 10 squared, plus BC, which is 28, minus 2 times 10 times 28 times the cosine of 70. Now remember, I told you that you don't have to use your calculator twice to get the answer, or 3 times. You can do it once, so this will be AC equal to the square root of 10 squared plus 28 squared minus 2 times 10 times 28 times cosine of 70. Can someone tell us the answer?
26.31.
26.31. 26.31.
If you round it off.
Okay. Well, let's round it off for now. But we might, because we are going to need that value, okay? It means our answer might slightly exaggerate, but it's fine. So we use 26.31. So we now know that the size of AC is 26.31 centimeters. And these are centimeters, by the way. Can you please do me a favor? I expect everybody to be paying attention. Okay? I expect everyone to be paying attention. So, now that we know the length of AC, okay? We now have to calculate the size of this angle. Once we know this angle, because AD is parallel to BC, therefore means that angle DAC is going to be equal to that angle because they are alternate. And once we get this angle, we can also get that angle there, that is angle BAC. And the question becomes a piece of cake after that. Okay? So, let's calculate the size of BCA. Okay? To calculate BCA, we are spoiled for choice now. But the best way is to use the sine rule. Okay? That's the best way. I will not encourage you to use the cosine rule, but you have to use the sine rule. Can you pay attention? Can you tell us to pay attention? Did you do this question at home? Yeah, then you're supposed to pay attention. The bulk of you didn't do it, so I expect you to pay attention. Your September control test, you will see questions like this. And you have to know what to do. And I'll make sure that there is a challenging question. Alright, so here, if we use the sine rule, I want to calculate this angle here. I know the side opposite it. Fortunately, I know the side of angle B and the side of AC. I can't use VC and this angle because I don't know the side of this angle. Unless if I calculate it. Okay, I don't know BAC. I can calculate it, but it will be very complex without knowing angle C. So it's better to use what? To just use angle B and AC and also angle BCA and AB to make things easy. So I'm going to write, okay, in terms of notation, so this is important. In terms of notation, remember you did geometry. Don't forget that you did geometry in term what? Term 2. So we can call this one C1 and that one C2. You can call that one A1 and that one A2. You can label it the way you want. Please, there is no specific rule up there. Okay, you can also name the angle the way you like. You can call it ACB, or you can call it BCA, you can call it C1, it's the same. Okay, well, allow me to just call it C1. So I'm going to say C1 over A, so AB over sine C1. So it will be AB over sine of angle C1. I'm being very specific. Okay? I'm using the sine rule. Why am I using the sine rule? Because I know this length and that length. Okay? And I also know this angle here. So this angle is opposite the given length, which I calculated, and AB is opposite the angle that I want to calculate. Therefore, I can use the sine. So the next ratio, I've used AB and C1. The next one, you will say AC over sine. So it will be AC over sine B. Okay? Now, what am I supposed to calculate is this C1 here. So I'll substitute my AB is 10 over sine C1. This will be equal to AC. Now AC is 26.31 over sine 70 degrees. Now, can I have your attention? Can you put your pen down and look? When you get to this point here, what are we trying to calculate? C1, right? So let's cross multiply. If you want to cross multiply here, remember, cross multiply like that. Okay? So I can write this as, at this stage, I don't want to skip a step. So that will be equal to 26.31 times sine of angle C. I'm sure that makes sense. Right? Then we divide both sides by 26.31. If we do that, we can end up having sine C1 is equal to 10 sine 70 over 26.31. Okay? Now, going forward, there is no reason why you should find the answer on the right hand side by using a calculator. We can get the size of angle C straight away. So this will be C1 will be equal to, remember, this is a ratio. This is a ratio. If you try to use the calculator many times there, you can end up wasting unnecessary time. But you can put everything in the calculator. Okay, how do you do that? Okay, I've got my calculator there, I'll show you just now. Okay, so angle C1 will be equal to shift sine of that whole fraction. So it will be 10 sine 70 divided by 26.31. Well, I'm trying to avoid a situation where I will round off again. Okay, I've rounded off already to get that 26.31. But by doing that, I'm minimizing rounding off for the second time. Okay, so take out the calculator. You have to get good of the calculator, I told you. So, yeah, I need to stop and let me remove that. Right, you have to be a guru of your calculator. So first you must press shift, then sine. Okay? You have to know your calculator very well. Then you put the fraction option. Okay? Just give me a second. Right? Put the fraction option. Then you put the numerator inside the brackets. So that's 10 sine. Okay. I think I need to close some of my apps, but anyway, let me use that option there. Sine. Well, our angle is 70. Then I'll close the bracket. Okay. Then I'll put the 26,31 in the numerator. Then I'll close the bracket now, the bigger bracket. Okay? Don't expect to get math error. I did correct. Right? So we'll get our angle. So our angle will be what? 20,93 degrees. Okay? So the angle will be 20,93. So angle C1 is 20,93. Are you following? Huh? Okay, so this is not the answer, remember. We want to calculate the size of, we want to calculate the length of CD. So I now know the size of this angle is 20,93. Okay? So the size of A1 is going to be 20,93 as well. So allow me to just write, based on my diagram, A1 also equal to 20,93. And I have to give a reason here because, okay, so this will be alternate angles. Then I must state that AD is parallel to BC. Okay? Then, now that I know the size of this angle A1, okay, then I want to calculate the size of CD. Well, I can just use the cosine ruler. Okay? I can use the cosine rule. I think for me that will be the better option because I will know the length of AG, I know the length of AC, I know the size of this angle, so I can use the cosine rule to calculate CD. That would be, I think, the best way here, based on all the information we have. So I'm going to write CD squared is going to be equal to, okay, again we are going to apply the cosine rule. So it will be CD squared will be equal to CD squared will be equal to AD squared plus AC squared. So it will be AD squared plus AC squared minus 2AD times AC, then cosine. Now, be very careful here. The cosine here, our angle is going to be A1. If you pay attention, please, when you have got more than one angle at a vertex, you need to be very specific about which angle you are dealing with. You need to be very, very specific. So my angle is A1. So this will be cos A1. So that's the cosine. Sometimes you get a mark just for writing the cosine rule for that specific question correctly. You get a mark. Right? Then let's carry on. What is AD equal to? AD is 12 and AC is 26,3y. Okay? AD is 12, and that's 26,31 minus 2 times 12 times 26,31 times the cosine. Now that will be the cosine of 20,93 degrees. This is CD. Okay. Then our CD equals the square root of everything there. Well, I'll just write as 12 squared plus 26.31 minus 2 times 12 times 26.31 cosine of 20.92. Okay. Can you? Huh?
Why not square 26.31?
Why is the mistake?
Oh, okay.
Please just square. Okay, what answer do you get?
It depends on your rounding.
Okay, at least we have rounded up once. We didn't do it twice. Actually, twice goes of that 20.9. But can you give us the answer?
Okay, this is the way that I did this, and I got the same answer.
Is this 07?
Yes. Oh no, that's a mistake. It's 15.7.
I'll give you an opportunity to explain to us. Right, so that would be. Okay, that's the same thing. Okay. Right. Please be aware that this question, this may not be the only way of doing the question. So we are going to give Sean an opportunity to explain to us how he approached the question.